All right, tonight I want to discuss about, I don't know if the stupid pen would work. One moment, please. All right, fresh battery helps. All right, here we go. So, tonight I want to talk about area between curves. So, the other day we talked about the definite integral. I don't know what that says. We talked about the definite integral, and recall that if I take the definite integral from a to b of f of x dx, what that's saying is you've got, well, here's your curve, here's a, here's b, the integral is that thing. Okay? So the question then becomes, well, wait a minute, what if you have f of x and g of x? All right, that's hot. And you want to find the area between them on some interval from a to b. Okay, well, let's think about this for a minute. If you did the integral of f of x dx from a to b, you would get this region here. Yes? And if you did, my pen is freezing. If you did the, go away, you hippie. If you did the integral, I don't know what that is, the integral of g of x, oh, there you go. If you did the integral of g of x dx from a to b, you would get this region. And so it makes sense that the interval between them would be the difference of those two integrals. And so you get the integral of a to b of f of x minus the integral of dx, don't forget that, minus the integral from a to b of g of x dx is equal to the area between f and g on that interval. Now, a couple things to think about. Okay, well, first of all, this is the same thing as saying this. So in other words, you could subtract them individually. Now, I'm going to do a couple of examples of that in a minute. So that's number one. That is a key feature. Frequently, we'll be given a function, maybe it looks like this. I don't know. Or x sine x minus 3x plus 5. And I don't know, 2 to 3, doesn't matter, whatever. Then I need to do the antiderivative of that. Okay? Well, this portion here is easy. And so a guy might do this. I'll do this part here. Piece of cake. You betcha. No problem. This part here, you're like, Groom, that's going to be a problem. You haven't taught us how to do that yet. No, and I won't for a while. But when I do teach you the antiderivative of that thing, when I do, I will do that piece individually. So that's the idea, is I can always separate these pieces in and out. Again, pretty cool because we're finding the area between the curves. Take the top one minus the bottom one. But that leads us to this minus this can be rewritten as this formula. Or if I start here, I can then break it back apart into two pieces, which again, always true. Same ditto, by the way, like, Groom, what would the total area between under these two curves be? What do you mean? Well, I have the area under this curve, and I have the area under this curve. Well, you just plus them, right? Now, we don't do that very often, but it's that same idea from the previous problem, f of x plus g of x dx is what that would be saying. And the idea being, of course, is you can do them individually. Again, if this piece is maybe messier, you want to do this integral by itself so you don't get confused. I don't blame you. I would too, f of x dx. Whereas this piece here, maybe the answer is easy. You can do it in your head, 5 or something. All right, cool. Then do it in your head. Piece of cake. I can break it apart. That's where we're going to actually use this. You with me, Joe? We're not Okay, going to be finding areas between curves a ton. Although we will do it, but we're not going to do it a ton. Again, area between curves is always a minus scenario. Okay, so that's number one. Number two thing I want to talk about is this. I'm going to change pens. The first thing I'm going to do. All right, so that's true. F of x plus g of x, f of x plus or minus, I can break them apart. So that's number one thing I want you to really take away from after the fact. We're just minusing to them. Okay. Gosh, I feel like there's something else. I don't care. I'm going to do an example here. So let's say you want to find the area between. Now let's look at Desmos real quick. Just pull one up here so we can just do one. It's just easier than trying to come up with one off the top of my head. Come on, baby. Give it to me. You can do it. Shoot, what the heck, bro? Desmos.com. Graph a function. Okay. What the heck, bro? Bruh. Okay, here we go. So, for instance, let's say your f of x was x minus x. Dad, blame it. X squared. X squared. What? You stupid hippie. Yay. Plus 5. All right, that's hot. Now, just FYI, if you're looking at this, if you're playing along at him, those are all 1 by 1 squares. You with me? So yesterday, when we did this problem, we're going to go and count our squares again. So I'm going to go ahead and find this one just for fun. So x minus x squared plus 5. And let's go ahead and do it on the entire, let's just do this one on the entire interval. It's a good repeat from yesterday. So if I'm doing this, I'm doing it from negative 1.79 to 2.79, if that's what I wanted to know. Of course, I can do it on any interval I want to. I just happen to choose this one. So it's going to be x squared over 2, x cubed over 3 plus 5x. Nice. Okay, I can graph those. You can use Desmos if that makes you happy. I'm probably just going to use my calculator because I'm lazy. Oh, good Lord. You idiot. It's not x to the 22 power. That's more better. Huh? So it's 14 minus that. So another answer is about 18 squares. Well, if you count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to say 14. 15. Yeah, I'd buy that. That looks like about 18 1 by 1 squares. Now, let's graph another function here. 5x. No, 5 minus x. Oh, that's hot. Now, let's say I want to find the area between those two curves. Okay, well, the obvious place would be from there to there. You with me? It'd be from there to there. Okay, so that's interesting. Now, so it means, if you look at this, Groom, you already did this integral. No, I did the antiderivative. What I didn't do is I didn't come back and use in this case, I want to use a different, I want to use 0 to 2 for my limits of integration, because I didn't want to find the entire area between the x-axis and that. I just wanted to know on the interval from 0 to 2. And so if you do that, you get 2 minus 8/3 plus 10. Of course, the bottom is 0. And so 12 minus was it 2 2/3, I guess. And so the answer is 9.33333. Yay! That would be that area. Are you with me? Now, the integral from 0 to 2 of 5 minus x dx, don't forget your dx, is equal to 5x minus x squared over 2 from 0 to 2. Well, if you do that, you're going to get 10 minus 2 is 8. You with me? And now, therefore, the answer then is 9.33 minus 8. The final answer is 1.33. Or 4/3, if that makes you happy. Nice. But Groom, you said we could do it in one fell swoop. I did say that, didn't I? So watch me. That's x minus x squared plus 5. That's the top function minus the bottom function. Whoa. And if you do this, lo and behold, what do you get? Well, you get, this becomes, what did I say? Oh, yeah, that's right. Yeah, for real. And so this becomes minus 5 and plus x. So you're going to get 2x minus x squared, and then the 5's go away. And now if you integrate from 0 to 2, what you're going to end up with is x squared minus x cubed over 3. Wait a minute. What happened to my 5x? Well, you had a positive one and a negative one. You goof and they cancel out. Remember, it's this minus this. So the 5x is, this becomes a minus. You get 2x squareds over 2, or in other words, just x squared. 0 to 2, you're going to get 4 minus 8/3. This is 12/3 minus 8/3 is 4/3. Hey, that's the same answer. Yay, we did it. That's hot. Again, we can do this till we are blue in the face. It's not hard. Groom, could you do another one? Well, by George, if you insist. Let's do this feller here. Now remember, a guy's got to do ones that we know the antiderivatives for, right? In other words, I can't just make one up. Well, I could. Oops, I could, but the problem is, no, but I'd have to kill you. No, the problem is if I do that, I have to know the antiderivatives for it. In other words, so just be careful of that. So negative x squared plus 3x. Oh, yeah, that's great. Groom, I would like to... No. Oh, not that much, dummy. Yes, that's it right there. That's it. But I want to find the area from 2 to 3. From x equals 2. But why? Because I feel like it, bro. I'm the teacher. I do whatever the heck I want to do. Well, I mean, within reason. You got me. So I want to find this region in here, yes? Inside of that, yeah. So it's going to be the green function. So sine x plus 5 minus the bottom function, which is negative x squared plus 4x. And then over the one in question, which is 2 to 3. Is that what I said? I didn't pay attention to myself. Yes, good for me. Nice. And so when you do this, this just becomes positive x squared, yes? And minus 4x, right? Because that's all we're doing. And now off to the races we go, right? Antiderivative of sine. Well, that is the negative cosine. Plus 5x plus x squared cubed over 3 minus 2x squared from 2 to 3. Now, again, I don't know that. By the way, make sure that you're in radians anytime you're doing derivatives or integrals. Every time. You ask why. Well, here's the thing. Remember, radians has to do with an actual distance around a circle. Okay, and so when we're doing things like how far did we travel, that's an actual distance when I do radians. When I do degrees, it's just a number of times I rotate, which doesn't mean anything to me. Are you with me? And such that x equals 3 And of course, I could just as easily have graphed this on... I could just easily have graphed that on Desmos. So that's going to be 6.98. So the answer is going to be 1.9 when I minus them. Okay? Again, in Desmos over here, I could have graphed negative cosine x plus 5x minus plus x cubed over 3. Oops. X cubed divided by 3 plus 2x squared. Okay, so there's your formula. You're like, what does that mean to me? Well, nothing much yet, but hang tight. So what I can do is actually zoom out a ways to see where these guys cross. Oopsie-daisy. Whoopsie-daisy. Did I mess something up? X cubed over 3. 2x squared from 2 to 3. One moment, please. Let's make sure that we are in the appropriate... Oh, I know what the problem is. We're in radians. Gotta be in radians. There it is. Yes, radians. What's happening? Okay, so we gotta try this again. So something's weird is happening. Okay, so let's see if we can figure it out. Over here, when Groom typed it in, let's see what he got. So he had... That looks all good. Oh, you buffoon, it's a minus. What a buffoon. Oh, that's more better. Yay. So as you can see, I got 5.08, 6.98, 6.98 minus 5.08, 1.9. Ta-da! And that 1.9 is the number of boxes of area between those two curves. Now, again, if you get it out to where they're 1 by 1 boxes, there's one full box, obviously. And then this partial box here and this partial box here, lo and behold, awfully close to what? Awfully close to 2, baby. 1.9 is what I would call it. Okay? That's the game. We're doing area, again, between curves. They don't have to cross, but they can cross. Okay, now, what if you did this one? This is probably the last one. Again, I don't want to sit here and belittle your intelligence. You know what I'm saying? I feel like you're smart individuals. 2x. Boom. Done. Oh, that's great. And, plus 1. Sure, plus 1. Plus 1. And then let's do x squared. Okay, now be careful. You're like, Groom, it's obvious. I want to find the area where they overlap each other. Well, maybe you do, but maybe that's not what the book asks for. So if I'm doing this, make sure you're paying attention to your limits of integration. Did we just say find the area between the curves? With nothing else, I mean just boom in that area, obviously. But if I didn't say that, then I can't assume that. So let's go from x equal 1 to x equal 3. Whoa! What do you notice, bro? What I notice is that between 1 and 2.4, purple is on top and black is on the bottom. But between 2.4 and 3, it's the other way around. Remember, it's always the integral of the top function minus the bottom function. That is on the interval in question. Okay, so again, from 1 to 2.4, it is the top function, which is 2x plus 1. 2x plus 1 minus x squared. And then I need to take that area, and I need to go from 2.4 to 3 of x squared minus 2x minus 1. I minus them the other direction. Okay, again, because we're looking for just how much area is between them. Well, the nice thing about this, of course, is once you've done the antiderivative once, it's pert near the same thing. It's going to be x squared plus x minus x cubed over 3 from 1 to 2.4, obviously, plus And then this is going to, of course, be what? Well, it's going to be x cubed over 3. Now, don't add them, for heaven's sakes. You cannot add these because they're on different intervals. So we're going to evaluate them. And then when we get all done, when we get done evaluating them, then we're just going to add the two summations when we're done. So it's going to be x squared plus x minus x cubed over 3 such that x equals 2.4. And again, such that x equals 1. And so 3.552 minus 5/3, 1.88. Plus, and then we're going to do this fellow over here. Now, again, that's going to be negative x cubed divided by 3 minus x squared minus x such that x equals 3. And such that x equals 2.4. Oop. Okay. Before you get all concerned, I see it. I see it too. What a buffoon. Here, get over there, you dumbass. Minus. Let's try it again, Jay. No, okay. And let's do it again for 3. Okay, so we're going to take negative 21 minus... Uh-oh. Something went wrong. Something went terribly, terribly awry. Let's go look at our graph again. We did black, which is x squared, minus the other two. From 2.41 to 3. Okay, let's try it again. So I did black, which was x squared, minus these guys. Okay, let's try it again. I feel like I messed something up. Oh, it's you dumbass. You got... Let's try it again. Let's don't put the negative in front of the x cubed this time, moron. You with me? What an idiot. What a buffoon. Again, that should not come out to be negative because we did top minus bottom. So you take negative 3 minus a minus, and lo and behold, I get 0.552. 0.552, which is 2.3. You with me? Roughly. So you come back to your picture, okay, in this region, again, if you zoom in a skosh, okay, in here, in this region in here, I see at least 1 and not quite 2. And then, of course, over here, you get about another half of a 1 in this region here. Again, that's not going to prove it to me, but it helps me realize, it's probably in the ballpark. It certainly isn't 512. It certainly isn't negative. You cannot get an area between, in this region and here, somewhere between here and here, in this region here, you cannot get a negative if you take the top minus the bottom. Ditto over here. Black minus purple on this one over here, you cannot get a negative because it's top minus bottom. It can't be done. Again, what would happen if you did do it backwards? Well, you'd get a negative. You'd get a negative because you take in a smaller area minus a bigger area. So that's silly. Don't do that. Okay? Always top minus bottom. Okay, we'll talk more about this next week. Have a good weekend.